Hi everybody, welcome back again. This is the last part of section 2 of chapter 10. In a previous video we did the first part of section 2, and this is finishing it up. I broke it into two parts because the first part was on tropical cyclones, like hurricanes and typhoons. And the last little bit right here is going to be on extratropical cyclones, which I said we're also going to refer to as mid-latitude cyclones. All right, so they don't form near the equator, but they form at a little bit higher latitudes. Okay, so in order for these storms to occur, and by the way, they don't form exactly the same way that hurricanes do. They actually form as a result of fronts. In order for them to occur, you need a pretty steep temperature gradient at the surface. Now, what I mean by that is, let's pretend this is the surface of the Earth right there. Okay, and as you go up, let's see if I can sort of shade this accordingly. You want it to be maybe warm at the surface. Okay, so I'm going to, excuse me a minute here. All right, so it might be kind of like warm air at the surface, but as you go up, it's going to very, very rapidly get colder and colder and colder. All right, that's what we call a temperature gradient, a steep temperature gradient. So I realize that these look just like a bunch of colors, but as you go up higher and higher, it gets considerably colder and colder. And the reason for that, so it's like really, really cold up here. All right, if you have an air mass that's rising up off the ground right here. Oh, that's a big fat air mass. Sorry. Let's do my skinny. There we go. All right. There we go. There's a cloud rising up, and it's warm air rising up. As it rises up, if the surrounding air is, so say this is warm right here, if the surrounding air is colder and colder and colder, that warm air will continue to rise and continue to rise, continue to rise if the surrounding air is colder and colder and colder. So that's why we say a steep temperature gradient is very important to keeping these things going. All right, so as long as the surrounding air gets colder and colder faster, rising warm air is going to continue to rise up. All right. And jet streams also have kind of play a part in the formation of mid-latitude or extratropical cyclones as well. Jet streams, or you could think of them as being kind of like rivers of air at very high altitudes off the ground. And I think it was mentioned before in a previous chapter that there are two main ones that affect our hemisphere: the polar jet stream and the subtropical jet stream. All right. Well, what the jet stream is like I said, it's a river of air that kind of winds around the Earth and just kind of encircles the Earth like that. And it creates all these ridges right here and all these troughs. It kind of meanders back and forth. All right, so this would be a high pressure area right here, and this would be a low pressure. I should do that in red, actually. Red and low pressure is usually warm air. I'll do it in orange. There's usually a low pressure right there. So jet streams, what they do is they tend to separate areas that have areas of high and low pressure and sort of isolate them into little blobs of high and low pressure. So cyclones, these storms that we're talking about, oftentimes develop in the curves of jet streams. Right? Cyclones are areas of low pressure. So wherever you have a trough like that, you're likely to have a cyclone occurring right there. And this diagram right here kind of shows that as well. All right, we tend to be affected by the polar jet stream. That is where we live. And so where you have a trough right here, you're likely to have a cyclone kind of spinning up in there. All right, because that's low pressure. All right, we know from before that high pressure, like a ridge right there, see that ridge, like that bump up. High pressure produces clear weather, but of course low pressure produces stormy, cloudy weather. So it's in this trough right here that we're likely to have some sort of a cyclone or some sort of a storm forming. Okay, so the jet streams really do play a part in directing the path of these storms across our continent. One thing that the jet stream actually does is it pulls warm, moist air off of Hawaii, and that's given the kind of the nickname the Pineapple Express. All right, now that just refers to an air mass right there, but most of the systems that come across our continent, or many of them, I should say, originate with this blob of warm, humid air coming from Hawaii called the Pineapple Express. It's called that because Hawaii is known for its pineapples and all kinds of other tropical fruit. So we'll see in just a second right here. You can see this big jet of warm, humid air coming from the direction of Hawaii. That's what we call the Pineapple Express. There's other types of cyclones called nor'easters that we get where we live more often, that occur when the polar jet stream kind of affects the North Atlantic and pulls humid air in off of the North Atlantic. But for the right now, we're just going to look at where the Pineapple Express comes from. All right, so you see this big, well, first of all, you see this this kind of this big comma-shaped storm right there. That's very common. That's going to be, actually there's another one right there. There's one there and like a much bigger one there. It's a big comma shape. This jet of, this big blob of warm, humid air is coming from the direction of Hawaii. That's nicknamed the Pineapple Express. And so as it rises and cools and condenses, it forms this big comma-shaped cyclone. You can see it's not perfectly circular. Like I've been saying, it's kind of a comma shape. So it doesn't form the same way that a hurricane does, but rather it's this shape, and we're going to actually go through a diagram of talking about the formation of a mid-latitude or extratropical cyclone, and it will explain exactly why it takes this shape right here. So I could just go ahead and read all this to you. What we're going to do is actually, we're going to draw this in 6 stages. Okay, and so what I'm going to do right here, instead of reading it all to you, you can take your notes, but what I'm going to do is I'm going to label what each stage, or what each description, with each stage, each description corresponds to. Does that make sense? So we're going to label these different bullets 1 through 6, all right? And the first of which is this right here, okay? There's a cold front on the southwest and a warm front on the east. It basically forms a stationary front. Stationary front. And this is where we talked about how two air masses come together, one warm and one cold, and they don't really push each other out of the way, but they start to rotate around each other. All right, well, that's what happens in part 2. They start to rotate or circulate counterclockwise. These two air masses move around each other instead of trying to push each other out of the way. All right. This term conveyor belt, it simply means the blob of warm air. All right, the mass of warm air. This starts to then rise up over the blob of cold air. All right, so that's going to be part 3 right here. And if you need to come back and see this later on and compare it to our diagram, you're more than welcome to. All right. But the warm air rises up over cold air, all right? It rises up more and more, and there's sort of a second phase of that as well. And then what happens is the warm air kind of pinches the cold air kind of pinches the warm air and forces it up towards the sky. So this is stage 5 right here. We call that an occlusion. All right, and again, if you compare this to stage 5 in our diagram, it'll make more sense. And then finally, stage 6 is all the cold air has pinched underneath the warm air. All the warm air has been forced upwards. And so all the warm air is on the top, all the cold air is on the bottom, and then everything's stable. Because warm air wants to go up, cold air wants to go down. But it's been this progress of cold air pinching around warm air that forces it upwards and causes the air to cool and condense and produce a storm that we see. All right, this next diagram right here is kind of a quick version of that. So this would be stage 1. All right, stage 2. We are going to redraw this in our diagram a little bit later on, but maybe this will help you. This would be stage 3. Stage 4, kind of an advanced form of that. And you can see right here we have occlusion taking place. See that kind of seam right there? That's where the warm air has actually been cut off from the ground by the cold air pinching underneath it. Stage 5, right here. We have a full occluded front, and as all this warm air is being forced upwards, the cold air is pinching underneath it, and finally we have stable conditions again at stage 6 right there. Everything is where it wants to be, and everything stops trying to push each other out of the way. All right, so what we're going to have a separate diagram about that, and I'm going to walk you through it again, but those are basically the 6 stages that feed that. This last slide right here, I'm just going to point out is a, where is it? Right there. This cold front and this warm front is a very common, well, you can see it right here too, cold front and warm front, and you see this sort of comma shape. This is a very common formation as a cyclone, mid-latitude or extratropical cyclone comes across our continent right here. And you can see this big comma shape right there. It's all because of warm air that is being pinched from underneath by cold air. So cold air is kind of pinching under there, and it's also cold air over here too. And the warm air is rising up and spiraling counterclockwise, giving us that typical comma shape right there. All right, so that's it for the second section of Chapter 10 notes. Oh, I'm sorry, the second section of Part 2 of Chapter 10 notes. The first section was on tropical cyclones. And I'll look for you in the next video where we're going to go through the 6 stages of the formation of a mid-latitude cyclone and make some more sense about these that we just looked at a minute ago. So in the meantime, thanks for watching, and I'll see you on the next one.